Hello students, welcome to my channel Experience of Physics, and in this class we will be seeing one topic from basic mathematics part. Right. So a concept from mathematics part is to be discussed in this class. Right. This is very fundamental topic, but learning this topic will be very much useful for us to solve problems in physics. Right. One is from differentiation and another is from integration. Two formulas I am going to discuss now. Only two formulas. In fact, only one formula. Only one formula, how it is done in differentiation and how it is done in integration. In fact, this is the very first formula people will be studying under mathematics. Right. Please see the title, Power Play in Calculus, but there is no such concept in calculus, power play. Right. Power play is the word I coined. Right. That is, I am going to play with powers. Play with powers. For easy remembering. So this will be very useful for the students who are the beginners of calculus. Right. So I have taken only the polynomial function. Right. Many functions we have to differentiate, many functions we have to integrate. But I will be teaching you only the polynomial function, not exponential function, not trigonometry function, not logarithmic function, right? Polynomial function, right? Say differentiation of x power n. Differentiation of x power n. The formula is n x into n minus 1. This side, integral of x power n dx, which is equal to x power n plus 1 divided by n plus 1. In fact, one constant will be coming, right? The limits are given, the constant value will be obtained, right? So this is important. X n plus 1, the power n plus 1 divided by n plus 1. So only the polynomial function. Assume y is equal to function of s. Let me write y is equal to function of x. That is, y is varying with respect to x. I want to find dy by dx of it. Say this is x power n. Y is equal to x power n. So dy by dx, I will be writing d by dx of x power n. Instead of y, I will write x power n. This is n into x power n minus 1. This is a formula. Right. For integration, y dx is equal to integral of x power n dx, which is equal to x power n plus 1 divided by n plus 1. In all mathematics books, you will be seeing these formulas. For differentiation of x power n, x power n minus 1, integration of x power n, x power n plus 1 divided by n plus 1. Right. This is how I will remember these two formulas. Right. Differentiation and integration. Two steps we are doing. This is differentiation and integration. Two steps. Step number 1, multiply the variable with old power, that is given power. Old power is given power, right? For integration, divide the variable with new power. Step 2, decrease the power by 1. Here in integration, increase the power by 1. Multiply with old power, divide with the new power. Decrease the power by 1, increase the power by 1. Here in step number 1, multiplication, but division is in step number 2. Decrement, power decrement in step number 2, power increment in step number 1. Right. You know, the integration is the reverse process of differentiation. Differentiation and integration are reverse processes. Right. Here multiply, here divide. Old power, new power. Decrease, increase. For differentiation, you can match the letters D and D. Decrease the power. For integration, you can match the words I and I. Right. The given polynomial is y is equal to x power n. Y is equal to x power n. This is what we are given. Y is equal to x power n. Multiply with old power. X power n is given. X power n is given. Multiply with old power. Multiply with old power. N is the old power. Yes. The variable is x. The variable is multiplied with the old power. Then decrease the power by 1. Yes. Over. Here, increase the power by 1. First you increase the power by 1. Incremented. Here n minus 1, here it is n plus 1. Then divide with the new power. New power is n plus 1. Yes, over. This formula for integration, right? So multiply with old power, then you decrease. Increase the power by 1. That is in step number 1. Then you divide with the new power. That's all. This is one polynomial function, right? Let us take few examples. Y is equal to x power 4. Find dy by dx. Dy by dx. So dy by dx is equal to d by dx of, instead of y we have to write x power 4. Multiply with the old power. Old power is 4. Then decrease the power, d and d. For differentiation, you decrease the power. 4 minus 1. So the answer is 4x power 3. So this is dy by dx. So you know it is the reverse process of differentiation is integration. Let us make the reverse process of 4x cube. So dy by dx is equal to 4x cube. We will start the integration process and see what will happen. So cross multiply it. Dy is equal to 4x cube dx. I am bringing y one side, I am bringing x one side. Separation of variables. Then you differentiate, then you integrate both sides. Integral of dy will be y only. Because a number 1 is here, if you integrate it, it will give you y only. Y is equal to integral of 4x cube. Straight away we will write four is a constant. For integration, you first increment the power. Increment the power. Then you divide with the new power. Increment the power. 3 plus 1, 4. New power is 4. 4 and 4 will get cancelled. Y is equal to x power 4. This is what we started from here. Y is equal to x power 4. When you differentiate it, 4x cube is the answer. If you integrate 4x cube, you will get y is equal to x power 4. Another example we will take. Let me write y is equal to root x. Find dy by dx. So root x can be written as x power of. Then dy by dx is equal to, first multiply with the power. Multiply the variable with the power. Then decrease the power. So of x, of minus 1 is minus of, right? This can be written as of 1 by x power of. This is written as 1 by 2, 1 by root x. X power of is root x. So since it is having minus sign, I am bringing to the denominator 1 by 2 constant, 1 by x power of is written as 1 by root x. So this will be the answer. If you take the reverse process for it, dy by dx, definitely you will get y is equal to root x. Then for the constants, if constants are given, how we can differentiate, how we can integrate, we will see. This is on graph x and y. Say y is equal to 5. Y is equal to 5. So 1, 2, 3, 4, 5. Y is equal to 5 means I am getting a constant line, horizontal line, flat line, right? Irrespective of the values of x, y is always constant, right? We have to differentiate it. So differentiation, second point you have to remember, differentiation is equal to slope of a curve. Differentiation equal to slope of a curve. This is one curve, y is equal to 5. What is the slope of it? Slope is equal to 0. So because it is a flat curve, right? So slope is equal to 0. So differentiation of any constant, d by dx, any constant is equal to 0 because the constant curve will never have a slope. Slope is equal to 0. So differentiation of constant is always 0, right? Then for integration, differentiation is equal to slope of a curve. Finding slope of a curve is differentiation process. Integration, area under the curve. Area under the curve. Let us have the same curve. This is y, this is x. I want to have integral of y dx. Here differentiation of y, d by dx of y, which is equal to d by dx of 5 is equal to 0. This is what we obtained here. dy by dx is equal to d5 by dx is equal to 0. Here, instead of y, let me write here, this will be 5 into x. 5 into x. Area under the curve. This is the area. Area under the curve. This value is 5. This value x. Say assume this is one rectangle. This is one rectangle, area under the curve. Because this is a regular shape, 5 into x will be the value. So integral of 5 dx is equal to integral of is equal to x. If you have y is equal to 1, y dx is equal to 1 dx, so the answer will be x, right? So differentiation of d by dx of any constant is equal to 0. Integral of any constant is equal to x. If it is a constant into x, in fact, constant into x, so this is 2 dx is equal to 2x. 10 dx is equal to 10x, because this is the area under the curve. Assume one rectangle, constant is 2, this side is x, 2 into x, constant is 10, constant is 10, y is equal to 10, this is x, so the area is 10 into x, right? So here constant into x. If you have simply dx, so the answer will be x only, because here 1 is available, 1 into x, right? So the 2 points I have taught you, polynomial function without constant and with constant. Let us take one example. Say y is equal to 4x cube plus 5x square plus 7x plus 9. Let us find dy by dx for it. This is variable, and 9 is simply a constant. It is not 9x, it is 9 only, so it is a constant. So 4 into 4 is constant, it is written as such 4x cube. First you multiply with the old power, then you decrement it, 3 minus 1, 2. Decrement the power. 5 constant, it is written as such. Multiply with the old power is 2. Then decrement it, 2 minus 1 is 1, plus 7. Power is 1, x, decrement it. Already it is having only 1, the power is 1, 1 minus 1, plus differentiation of constant is 0. Right? Differentiation of constant is 0. So this is 12x square plus 10x plus 1 minus 1 is 0, x power is 1, so 7 into 1 only. X power 0, any number with power 0 is equal to 1, 1 into 1 is 1, 7 into 1 is 7 here, it is 0. So the answer is 12x square plus 10x plus 7 over. So for the same function, let us make one integration process. Find the result of integration of weight. 4x cube plus 5x square plus 7x plus 9. Integral of y dx is to be found. So integral of 4x cube plus 5x square plus 7x plus 9 dx. Instead of y, we are replacing the given polynomial. 4 is constant, right? First increment the power, x 3 plus 1, divided with the new power, 3 plus 1, plus 5 is constant. Increment the power, x cube, new power is 3. 7 is written, 7 constant, 7 is written as such. X power 1, so increment it, new power, plus 9 into x. So here differentiation of 9 is 0, but integration of 9 is not 0, 9 into x, area of the curve, right? Area of the curve. So this is 4 x power 4 divided by 4 plus 5 x cube divided by 3 plus 7 x square by 2 plus 9x. So the 4 can be removed. X power 4 plus 5 by 3x cube plus 7 by 2 x square plus 9x. This will be the answer. If you take differentiation for it, you will get this value. If you take integrate it, you will get this value. But here constant of integration we have not found because we have taken only simply without limit. Without limits only we are doing it, right? So this is a simple topic what I want to discuss with you in this video lecture. So this is the point, playing with the powers. That is why I made this title, power play in calculus, right? For differentiation, you have to decrease the power, but it is done in step number 2. For integration, you have to increase the power. It is done in step number 1. Reverse process, multiply, divide, old power, new power, decrease, increase. Step number 1, here step number 2, here step number 2, here step number 1. That's all, right? Thank you for watching, students. All the best.